Hi everyone, today is simple random sampling day 2. And in example number 10, it says identify whether the statement describes the descriptive or inferential statistics. Based on the data from from my group, I estimate average height. Example 10 is based on the little example that we did in class. That's I believe from 6 to 7, and we didn't quite do that yet. So we're gonna talk about it using the data I have collected before, and we're gonna describe it, and then we'll come back and try to finish it off. And they are talking about descriptive and inferential. Don't forget, descriptive is from small group to small group, and then inferential is gonna be the small to the big group. Okay, so we are going to do the project in class, so hopefully you understand when I go through it. Based on the data of my group, that's what from before, I estimated the average height of all the students in the school is 62 inches. So here's a couple things you have to keep in mind. Based on the data from my group, I estimate the average height of all the students in the school is 62 inches. So is that descriptive or is that inferential? Pause the video and answer question A and B. So for the inferential, for the letter A, inferential because data was from my group and conclusion is for a bigger population. B is the average height of 4 students in my group was 62 inches, and it's descriptive because use only samples from the group to conclude. So now what we're going to do is, now the next conclusion is conclusion for that is we differentiate these two types of numerical measurement with both symbols and words. We will learn the symbols later in the course. But right here we have the next thing, which is called statistics. The statistics is the numerical summary of the sample, and we use a symbol of S. So because we're talking about numeric, right here, we are going to talk about different kind of statistics. Statistics, the numerical summary of samples. So when you see the symbol like this, X with a bar over it, that's the average, and we are sometimes use the word mean, okay? And then parameter, the numerical part of it is going to be called the numerical summaries is going to be population. So statistics with a S sample. Parameter is going to with a P, so it's a population. And they do have a symbol also for that. So when you have population, it's going to be in mu, they call it mu, and that's going to be in percent. The reason for that is because population is so big, and there's no way you can actually identify how big is the population. So therefore, we try to do it in percent. Example 11. Let's say that we want to know the average lifetime of a particular brand of car battery. Gathering such information on a car battery results in batteries that cannot be used after this information is collected. Obviously, not all of the batteries can be tested, or all batteries will be dead. So instead, we could test a random choosing of 50 batteries and use these results to make conclusion about the average lifetime of all such batteries. Identify the following from the example. I'm gonna pause this and write things down, and you guys go ahead, give it a try and see can you find out the different information. Don't forget, parameter is going to be all the big picture population, and statistics is all the numerical sample. This parameter is numerical population. Descriptive is going to be small to small. Inferential is small to big. So pause the video and try to answer some of the questions, and let's go back, and then let's come back and talk about it. So for example 11, the answer for individual is going to be 1 car battery, and for the samples, it's going to be 50 batteries that's tested. That's the group that you're going to draw conclusion from. And the population is what they're going to talk about. What they're going to talk about all the batteries of that particular brand, what's going to happen? Statistics is the average lifetime of 50 battery. Remember, it's kind of the same thing as sample, but you are talking about the numbers, okay? And then the next one, the parameter, average lifetime of all the battery. So in this case, it's going to be in percentage. This one is going to be the mean. So maybe one battery will be going for 2 weeks, the other battery is 2.1 weeks. And then when you do that, it's going to be the average. This is going to be the average them together. Then what you're going to do is descriptive statistics reporting the average lifetime of the 50 tested battery. And then inferential statistics is going to be using the average lifetime of 50 tested battery to estimate the average lifetime of all the car batteries. Notice the difference. The sample is just testing it. And then statistics is what happened, how do you calculate that data? So 50 battery tested, one could be 3 out, one could be 3 weeks, the other one could be 4 weeks, the other one could be 3.75, all those numbers. And this one is averaging them together. So that is how you differentiate the sample and statistics. Example 12, let's say that a company wants to know the percentage of their product that don't meet certain certifications. A company does not have enough time or money to check every one of their products before they are distributed to the consumer. So they may test 30 products in a large shipment and make a decision about entire shipment's percentage of defectives. Based on the percentage of defectives in the sample of 30. Identify the following from the sample. All right. Individuals, samples, population, statistics. Remember, statistics is talking about the numbers. Parameter, those are average. Statistics average. Parameters average. Is it descriptive? Is it inferential? Now pause the video and write down some answer and let's come back and check. Do you have the same idea? For the individual, for the example 12, it should be just one product. You are talking about one piece of data, so it's one product. The sample is going to be they may test 30 products. So that's going to be the sample. They are testing 30 products. Population is all the product in the shipment, and because they are going to make a decision about the entire shipment percentage. Okay, and then what you're going to do is they have the statistics. Statistics is talking about the average of the percent defective in the 30 tested product. Statistics is the example. Then the parameter is average of percent defective in the whole shipment, and then the descriptive statistics is reporting the percentage defective in the 30 tested product, reporting the percentage of defective in the 30%. So if you notice, it is statistics and descriptive stats statistics is really similar, okay? And then the parameter is average of percentage of defective in the whole shipment. And same thing in the inferential statistics is using the percentage of defective in 30 test product to estimate. That's the keyword right here. You want to estimate the percentage of defectives in the whole shipment. So really the only a little bit difference is between parameter and inferential statistics is just adding that estimate in the whole wording situation. That's example 12. The next vocab is called variable, and which is we done it before. Variable is a characteristics of individual to be measured or observed. And the reason we are doing that is we are going to break down the variable into different categories. So we ask questions about characteristics or attribute that varies from person to person. Some samples question could be 1. What math class did you take last year? 2. How many classes are you taking this semester? 3. How long do you work at a job each week? Or 4. What is your zip code? Those are all different characteristics about a person. It could be more. There's plenty of questions you can ask. Going on to the next thing. So breaking down the variables, there's a couple things right here. Each question is collected a set of data for a variable. Some of the data collected will be
numerical, while some of them is categorical, name or label. We classify the variable data we collect as either. If you have a quantitative, I'd like to make sure that you guys understand the N part because that's going to be connected to numerical data. That's going to be a number data. Now, when you have that, the number can be counted, added, and measured, and that will make sense. Keep that in mind. The next one you have is qualitative. It's like a categorical. So there's an L right there, right here, and that's why categorical. That's qualitative, and I will usually say it more dramatic. A quality or attribute the individual have. So it's quality, okay? And moving on, we're going to talk about the examples here. So example 13, it says, in the list of questions from the previous page, identify the corresponding variables and whether the variable is quantitative or qualitative. What math class did you take last year? Well, some of you guys will have intermediate algebra. And because that's intermediate algebra, or you can say algebra 2, and that still is a category. It's not a number you can add or subtract or measure, all right? In this case, that's a qualitative. And the next one, how many classes are you taking this semester? That's numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this case, because it's numbers and we can count it, it's going to be quantitative. The next question says, how long do you work at a job each week? And that's also quantitative because it's an hour. You can add them. You work 2 hours. You did 2 hours and 30 minutes. And you can measure it. You can count it. So that is still going to be quantitative. Then what's their zip code? That is going to be a very challenging one because that's a location. That's not something you just kind of add up address numbers. You don't ask on your zip code and you don't measure your zip code. It's just a location. It's a characteristics. So therefore, this is actually, even though its number is qualitative, QUAL. So those are the 4 examples. And going on to the next one. When you need to summarize quantitative data, you calculate the average. You calculate the average and the mean. That's counted. But when you are summarizing qualitative, you will calculate the percentage of the characteristics found in data. So in this case, qualitative is you will say 30% of the population has eaten an apple, 1 apple kind of thing. And right here, you will do the average of people who sleep at night is 8 hours. That's how you decide on those things. Example number 14. Using the information in example number 11 and 12 to complete the table. Let's say we want to know the average lifetime of a brand of car battery. We test a random chosen 50 battery and record their lifetime. Identify the following. So in this individuals, 1 piece of information, and that 1 piece of information is going to be 1 battery. And the variables is going to be talking about how long is their lifetime. Let's say we want to know right here. We want to know average lifetime particular brand of car battery. When we talk about what kind of variable we are going to talk about the lifetime type of variable. Well, lifetime is going to be in calculation of time. So this is a quantitative variable. Then the last thing, a summary of statistics. Well, summary of statistics is going to be the average lifetime of tested battery. So it's average now. What we're going to do is that because we are talking in the small group, that's the sample group right here. Statistics is sample. So this is going to be average lifetime of tested battery. So now let's say the next example. The next example says, let's pause the video and then you guys try the next example. Okay, here's the answers. Individual, 1, so let's read through it. B, Let's say a company wants to know the percentage of their product that don't meet certain specification. We tested 30 products in the large shipment and classified each as good or defective. Right here, classify is each good or defective. Identify the following. First, individual. Individual is 1 product from the shipment. Next one, variable, defective or not, or you can say each is good or defective. Type of variable is going to be qualitative because it's good or defective. Summary statistics is going to be the percentage of defectives in the tested product because the statistics is the tested product because that's the sample. This is the sample. And connect the words with sample. And that is your example letter B. Then we have more little piece to cover on the quantitative variable. So you learned in algebra class that some quantitative variables are discrete. Okay, so now let's talk about what's discrete while others are continuous. We further classify qualitative variables, that's quantitative variables, into discrete or continuous in statistics. Quantitative discrete variable can countable, distinct number with no partial. No partial means no like decimals, no fractions, everything is just a whole number. 1, 2, 3, 4, 5. Then quantitative continuous variable is not countable measures because it just floats and there's no ending and there's no stopping. They are partials on a continuum. So that means you can have 1.1, 1.11, 1.1. You can have all kind of decimals and just would not stop. For example, a pi, a square root, all those things is possible. Or you can have repeating decimal 1.11111, and all those things are not countable measure because it goes on. It more likely will have approximation in that situation. I would like you guys to pause the video and give this a try. Is it discrete? Is it continuous? If it's discrete, it counts like an egg, 1, 2, 3, 4, 5, or your phone, 1, 2, 3, 4, 5. If it's continuous, it's things like a flow of the water or time of the clock. It just keep on going. Pause the video and try them.
So in this case, if we read through it, the number of days absent from classes, that's going to be discrete because you are talking about days. Even though you say, Ms. Wiseman, but there's partial days. Yes, but there's always something that does not keep on going. It doesn't flow. Okay, so that's why it's discrete. The next one is continuous, the amount of the time spent in studying for the first test. It could go on and on and on, and it flows from one thing to the next, 1 minute to the next, because there are seconds in between. So in this case, that's going to be continuous. The height of a student, that's continuous because you start growing when you were a little baby and you keep on growing. And yes, there will be a time to stop, but in the meantime, between when you're born and then when you stop, that's continuous. The next one is going to be the difference between two students' test scores, where tests are whole number points, and that's going to be discrete because that's just one number and another number. And those are the examples for discrete and continuous. That's the notes for today. Thank you so much for watching.